Assalamu alaikum. My name is Omar Nasser Arshid and my friend behind the camera Faisal Muhammad Shaya. Today we have the experiment of Biot Savart law, the straight conductor. We have two goals. First one, determination of the magnetic field of a straight conductor as a function of the current. Second one, determination of the magnetic field of a straight conductor as a function of the distance from the axis of the conductor. This is the equation for the straight conductor. P is a magnetic field equal permeability of free space over 2 pi multiplied by current over the distance from Hall sensor to the wire. Here we have three variables. We have to make two of them are constant. Mu naught in this room is constant, and r the distance from the Hall sensor to the wire. And we study the current and magnetic field. This is the power supply, and this the Tesla meter for show the magnetic field. This is the P probe, and this is the Hall sensor, is the end of the P probe. This is the wire, and so we increase the current to 2 ampere, and we see here in this meter the value of magnetic field is 17, the average. .17. Okay, we increase the current to 4 ampere. Okay, we see the magnetic field is 0.32, is 0.23, the average. Then we increase the current to 6 ampere. And we see here the magnetic field is increased to 0.33, the average. Okay, when we increase the current, the magnetic field will be increased.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Muhammad Wahid and my friend behind the camera Faisal Shaya. The second experiment today is the circular conductor loops. We have two goals in this experiment. But the first one, determination of the magnetic field of a conductor loop as a function of the current. And the second one is determination of the magnetic field of a circular conductor loop as a function of the loop radius and the distance from the loop. Here we have two equations. The first equation for a ring in electric field, and the second one is equation for Biot and Savart, as my friend say. We have to complete it together, and we will get the equation for find out the magnetic field, and this equation will be permeability multiplied current and the radius square over 2 radius square plus the distance from the center of loop to the Hall sensor we will get the magnetic field. Here we have 4 variables. We need to keep 3 of them constant and make study on one of them. We will keep permeability constant because in this room it will be constant, and the radius will be constant, and the distance from Hall sensor to the center of the loop will be constant, and we will study on the current. This is a power supply which voltage come out from it, and this is the loops, and this is the Hall sensor, and this is P probe. And this is the Tesla meter which measure the magnetic field. The first thing we must do, we will put the Hall sensor at the center of loop. And we don't need to use a scale for determining the center of loop, because the center of loop has a greater magnetic field. And we will apply the current. We'll apply 2 ampere, and we will get 0.10. Now we'll apply more voltage at 4 ampere, and we will get 0.16. Now we will apply more voltage at more current at 6 ampere. And we will get 0.24. Now, as the current is increased, the magnetic field will be increased.